Hi, I'm Dave and welcome to Carve Tools. Yesterday this large pine tree was hit by a lightning strike, and the energy that is produced from lightning will search out and destroy electrical appliances, electronic devices, and one of the many items in our house that is no longer working is the air conditioner. The thermostat indicates that the fan is on and it is cooling. It's 83 degrees and the fan or compressor is definitely not running. We are at the peak of summer and currently it is 81 degrees outside and headed to 92 today, so I better get started. Now we are so blessed to even have air conditioning, and in this video I will show you how I repaired the system myself without having to dig too deep into the emergency fund. This is a York system. It's a split system. It has the heat pump and air conditioner. The compressor is outside and the air handler and condenser coil is located inside. Now my terminology may not be exactly correct on some of these components, so just bear with me and I'll show you how I repaired the system. Removing the panel here on the outside unit, I will check for voltage. And it reads 246 volts AC, so that's a good sign. Hopefully the lightning did not damage the compressor, and a quick check for that is to momentarily press in the contactor with an insulated screwdriver. And there it goes. That's a great sign. The compressor and fan will run, so the outside unit is likely okay. But I really have no idea if the electronic control board was damaged at this point. The next step, I'm going to check the air handler unit inside. Now I'm removing the panel without turning off power. And I measure across the power terminals and it is 247 volts AC, so that's good. Inside the air handler is the fan and heat control board, and here is the control power transformer. I'm checking for 24 volts AC across the R and the C terminals, and there is nothing. Later in this video, I'll give you more detail about each terminal on the control board. Alright, so far I know there is no control power to the circuit board, but checking across the output of the control transformer, I have 28 volts. So this indicates to me that the fuse is blown. I disconnect the circuit breaker to the air handler. Looking in my fuse assortment, I actually had one 5-amp fuse just like I needed. I replaced the fuse and turned on the circuit breaker, and it blew. So there's a short somewhere. Disconnect the circuit breaker again, and I will remove the control wires, but I suspect that the control board is the actual problem. It's always a good idea to take a picture so you'll know where each wire is connected. I don't measure any shorts in the wiring, but when lightning strikes nearby, the energy can just go anywhere. It will search out random electrical and electronic devices, and you just never know. I remove the fan and heat control board so that way I can take a better look at it. Here's the removed control board, and I see there's an IC chip that may be damaged, and I suspect that this is probably where our short is caused. This is a York brand, and only a couple of suppliers are within 50 miles of here, so they're going to get you in the wallet. I could have saved about $65 if I purchased this online, but I didn't want to wait 3 to 5 days for it to arrive. So we are so spoiled here in America, we can't go without our air. I checked for the jumpers to be in the correct location. Here I connect all the wires except the control wiring. Remember to refer to your photo you took earlier and double check your connections. I turned on the 220 volt breaker and checked for control voltage. And there it is, 28 volts AC. This is what we were looking for. I'm going to disconnect the power again then connect the control wires, and I will refer to my photo to make sure I put them on the correct terminal. Okay, I told you I'd tell you a little bit about each terminal. This is the C terminal, and it is the common for 28 volts AC. There are two blue wires twisted together. One goes to the outside unit. The other supplies power to the thermostat, but in my case, the thermostat is battery powered and the blue wire is not actually used. The O terminal, this is for the reversing valve in heat mode. Now this is a heat pump with auxiliary heat strips, and there are two wires twisted together. One is orange, one is brown. One wire goes to the outside unit. That operates the reversing valve, and the other goes to the thermostat. The W2 terminal is for heat mode. Now brown is the normal color, but here the brown and white are tied together. Once again, one is from the thermostat, the other is to the outside unit, and it goes through this control board. The G terminal is a single green wire, and it's from the thermostat, and this is what controls the blower fan. The Y terminal is for cool air mode. That's what we want. There are two yellow wires, one from the thermostat and the other to the outside unit. The R terminal is power from the transformer. There are two red wires twisted together, one from the thermostat, the other to the outside unit. I'm going to double check the wiring. It all looks good. I'm going to go turn the circuit breaker on, and the fan should start running. Good, the blower is running. Shortly the compressor should turn on, and we're going to go check that outside right now. All right, here we are at the outside unit, and the compressor and fan should turn on just any second now. There it goes. Thank you, Jesus. We are back to cooling. So let's look what happened here. The AC stopped working due to the lightning strike on this pine tree. The energy somehow traveled to this control board. I replaced the damaged control board, $195. A few hours later, it's cool again. Thank you, Jesus. So that's how I repaired our air conditioner for $195. If this has been helpful to you, please subscribe, and a thumbs up is always appreciated. I'm Dave. This is Carve Tools. Have a great day.